Now I'm going to discuss about the power of silvering lens. I want to discuss about power of silvering lens. Silvering lens. So the first one case here that the double convex lens is silver one side, silver this side. So this is optic side. So in this case of silver, so while you are calculating the means is asked to find final focal length. The next step, image distance. Image distance. Then you give the U value to find out focal length, then you can find out images. Now the third one is graph. So now I'll discuss about it. Overall, silvering lens. So consider here you know, answer double convex lens and arranging this. Try silvering this side. I'm silvering one side. So then finally, after silvering, the lens behaves as mirror. Behaves as mirror. mean. So immediately we get the doubt. Behaves as mirror mean which type of mirror this is. So depends on sign of total power. Sign of total power. So that is positive. The silvering lens behaves like the silvering lens behaves as convex mirror. Note this point. The power is positive. The mirror behaves as convex, not concave mirror. Because in previous converging mirror has positive power. The power is negative. In total power of silvering lens, power is negative. It behaves as the silvering lens behaves as convex mirror. Convex mirror. So now, how to get the first of all power? So in that case, see if we see, for example, here consider an object. So the incident ray which is incident on the first surface of lens refract again to the mirror, so reflect, and again it is refracted. That means the total power in this case is equal to power of the lens plus power of the mirror plus power of the lens. That is equal to 2PL plus PM, power of the mirror. And we know the power is 1 by F. No, power is 1 by F. So now then power of a lens is equal to 1 by F of the lens, that is equal to NL by Nm minus 1 into 1 by R1 minus 1 by R. 1 by R1 minus 1 by R. So here R1 is what? The R1 is radius of first curvature. First refracting curvature. The R2 is second refracting radius of second refracting curvature. So why you have to consider first and the second curvature means for sign conversion purpose. When you are doing the problem, sign conversion you have to apply. So you know power of the mirror is equal to 1 by focal length of the mirror, that equal to 2 by R of the mirror, that equal to R equal to PF. That's why R by 2 of the mirror. So here it is very clear. I can go with R because therefore since why the second surface is silver. And that is behave like a mirror. So the focal length of the mirror equal 2 by R2. R2 I can take. So now consider here. So total power, in the calculation of total power, so total power is equal to P total final power is equal to 2 into, so NL by NM. I will take as relative refractive index N minus 1 into 1 by R1 minus 1 by R plus 2 by R. So this is the formula for total power. So now suppose the lens is this is now next one. The plane, no convex lens. So now see, now this is plane surface, silver here. This is convex surface. So this radius is R, that equal to R2 is equal to R. So in other case, so this is the convex surface and here is the plane surface. So this plane surface is silver. So here the R1 is equal to R, and you people know that the radius of plane mirror is infinite because it's the plane surface. So now in this case, so here is the object is there. So some distance. So the object distance is equal to you consider. So that value side can do the problem with taking some u value. So now, and this refractive index of this one. So the refractive index of this one is equal to 1.5. And radius of curvature is equal to 12 centimeter. So now how we'll follow the same like previous board. The power is equal to 2PL plus PM. So that is equal to 2 into PL means N minus 1 because here medium is air medium and the refractive index of the lens is N. So N minus 1 relative refractive index of this combination. And here R2 is, so here is the object is there. So this side. So here R2 is positive because the incident direction is this one. So this is the incident direction. So here there will be a C2. This distance is R2. So the radius is negative or positive because R2 is positive because in the direction of incident ray, that is, and R1 is infinity. Radius of plane mirror is infinity. Already we discussed. Therefore, 1 by infinity minus 1 by plus R. So that equal to 2 into 1.5 minus 1 into minus 1 by R. So that equal to here 1.5 minus 1 is 1 by 2 only. That equal to minus 1 by R. So that is equal to, so this is power of lens plus power of the mirror. That means 1 by focal length, 2 by R2, 2 by R1, sorry, 2 by R1. That equal to 0. So that equal to 1 by R2 minus 1 by R2, then 1 by minus 1 by 12 centimeter. You see here the power become, now the power become equal to 1 by FL, power become minus 1 by 12 centimeter. That means power is minus. So power is minus, no? Power is minus means this mirror is, so now the system is behaves like a convex mirror. Convex mirror. So you understand here. So if these values are not given, n value and r value, the power for plano convex lens and a plane surface silhouette is 2 of n minus 1 here and minus by r, radius of curvature. So power is becoming minus. Similarly, come to this example. So here also, so object is here. So now R1 is R and R2 is equal to here. R2 is equal to infinity. R1 is positive. So now power is equal to 2PL plus PL. This is common formula. So now that is equal to 2 into PL, 1 by FL. We know according to Lenzman formula, 1 by FL is equal to n minus 1 into 1 by R1 minus 1 by R2 plus power of the mirror is 2 by R2, that equal to infinity will become 0. That equal to of n minus 1 by R1. R1 is positive and here R2 is infinity 0 and R2 is infinity 0. So now that is equal to 2 into 1.5 minus 1, 1 by 2 by R1 is 12 centimeter. So now P is equal to here plus 1 by 12 centimeter. So see here the plus indicates this arrangement behaves as concave mirror. Because power positive means it is converging mirror, so concave mirror. Power is negative means it is convex mirror. So now here, from these two cases, in case 1, I got focal length is equal to minus 12 centimeter. And focal length is equal to, in case 2, focal length is equal to, here see, in case 1, convex length, then focal length is equal to plus 12 you have to take. This is the case you have to remember. While you are solving the problem related to, means in the second case problem, object distance, to find by giving the object distance to find out the image distance. Here the focal length, in this case you have to substitute the focal length is plus 12 centimeter, here minus 12 centimeter, right? So I'll come with one example. Now I will explain one example for previous class, this previous model. That means, so now I will take a concave lens. I will take a concave lens. Sorry. Can be happen. So now see, so now I will take a concave lens. In this problem. So now the concave lens. So anyhow, this is silvering we consider. This surface is silver. So here, opposite to the silvering surface, I am taking object. And here, the two surfaces, R1 is equal to R2. So that equal to 30 centimeter. Whereas, in this concave lens, this side is silver. Sorry for this convenience. So here is the object opposite to the silvering surface. And refractive index of this one, the lens is equal to the glass made up of glass. Therefore, maximum cases 1.5 cent. Refractive index is 1.5. Refractive index has no units. And here consider the object distance also. So the object distance, the U is equal to 30 centimeter. So then I need to find out first focal length is how much and V is equal to how much. After this other model we discuss. So now the same formula will go. That is the for silvering of lens, the formula is like this. The total power is equal to 2PL plus PL. So that is equal to 2 into n minus 1 into 1 by r1 minus 1 by r plus power of the mirror 2 by r. So now substitute all the values. 2 into n minus 1 already we know 1.5 minus 1 is equal to 1 by 2 into here r1 r2 are equal, and see here then it is not 0 because r1 is here negative, r2 is positive. R2 value is positive and R1 is negative according to sign conventions of here. So this is the instant direction. So the R1 is this one and this is R2 because center of this curvature is this side. This is the part of this sphere. This curvature is part of this sphere. The second curvature. And this curvature is part of this sphere. Right? So in terms and all we discussed already. So this side is C1 somewhere. So C1 because radius is given 30 centimeter, object also given 30 centimeter C1. So C2 also 30 centimeter C1. Then here if you see R1 and R2, R1 is negative, opposite to instant direction. And here the light is left to right. The light is traveling from left to right. Then optic center behaves like a origin. So according to mu Cartesian coordinate, this is the formula. Therefore here both are negative will come. That equal to minus 2 by 30 plus the 2 by, then R2 is positive, then 2 by 30. So this is get cancelled. So 2 get cancelled. That is equal to minus 2 by 30 plus 2 by 30. So is equal to 0. That means focal length is infinity. In this case, this behaves like focal length is infinity means behaves like mirror, plane mirror. Okay, guys. So guys, here small mistake. So here this is power of mirror is so this mirror is convex mirror, right? The mirror is convex mirror. Then power is negative, not positive. The power of the mirror is negative on sub. Here you have to substitute the negative. So that is the mistake. So now not 0. It is not correct. So now this is minus 4 by 30. So that equal to behaves like power is again negative came answer to me. Therefore it behaves like convex mirror. So sorry for mistake. So finally this is correct. Convex mirror. Now see. So your object distance is given 30 centimeter. So to find out V focal length I have to find out. So I know focal length is equal to 1 by P. So that equal to here P is equal to 4 by 30. Then focal length is equal to 30 by 4. So that equal to 7.5 centimeter. So this is the focal length. And as I said, convex mirror. Convex mirror has focal length positive. So in solvation, you have to take focal length is positive. Therefore, 1 by 7.5 is equal to the mirror formula, 1 by u. U is always negative. So that equal to minus 30 centimeter plus 1 by v. I need to find the v value. So no need to apply the sign convention. So this will become this side. That is 10 by 75 plus 1 by 30 is equal to 1 by v. 5 2 ja 5 15s, 575. That equal to LCM is 30. So 2 2 ja 4 plus 1 is equal to 1 by v. So v is equal to 30 by 5. That equal to 6 centimeters. Our answer is correct or not? We will verify. See, clear that is. So here focal length is how much I got? 7.5. So V is less than focal length. So this is the case. The V is less than in the focal length. In case of convex mirrors. Convex mirror. You are very clear, right? In convex mirror, V is less than F. That means image forms between focus and pole, right? Focus and pole. V is less than F. So our answer is correct. So this is the method to find focus length and means focal length and image distance when object is values are given. And here I did mistake, power of mirror. So here it is convex mirror, means this surface is silver. So the power is negative R total. So last model in this only, it is going to take long video. Anyhow, so if you take here, the small model I conclude. So that is, we see halo lens, means different type of lens. This is the convex lens. In the diagram, I am drawing somewhat thick, but our discussion belongs to only thin lenses. So this is a halo. So, and one side is silver. One side is silver. So now power of the lens will become, see, power means formula 1 by FL. So that equal to N minus 1 into 1 by R1 minus 1 by R. So if you see here, N means what? Relative refractive index, N of the lens by N of the mirror. So that is, in this case, halo lens case is 1. Therefore, power of length is coming 0. Power of lens is coming 0. This correct. And focal length is 10. But here our discussion is you have to find out the total power. It is the only power of lens. So then you have to find out the power of mirror. So then total power is equal to, the total power is equal to 2 PL. Anyhow, it is 0 plus PM. So here PM is mirror. And if you see here, the object is this side, light is going left to right. So all sign conventions are very clear. So PM is positive will come. That is equal to total power is equal to how much? 2 by R. So the R value is given means you can find out the power value, and here power is positive. So we already have taken it, the mirror is concave mirror. So power is positive is coming. So verify. So in another case, so the same convex lens or concave lens, whatever you can consider, not a problem. The same convex lens. So this is filled with water or any other liquid. And one side is silvered as usual. So now here, this refractive index, N of the medium is equal to 1 because air. Now N of the lens is equal to refractive index of water. Here I have taken water. If it is glass means already we have solved problem. And now water I will take. So now same process. The power is equal to 2PL plus PL. In silvering case, first power, then focal length, then mirror formula. Then here in the case of PL is equal to 1 by FL, lens maker's formula, you have to substitute. That means NL by NM, relative refractive index, minus 1 into 1 by R1 minus 1 by R. Plus 2 by R2, power of mirror. So now you are substituting the given values if they are given. So here NL by NM, that is equal to power of the lens. This is the total power, sorry. Here this is the power of the mirror. Sorry, I mean another mind. So now here see power of the lens. So that equal NL by NM minus 1. So here the refractive index of water is equal to, we know that value is, the refractive index of water is equal to 4 by 3. It is a known value. So now we substitute refractive index. So now here what will come? 4 by 3 plus 3 by 4. That equal to minus 1 by 3. 3 by 4, right? 4 will go out. 3, sorry. Here 4 by 3. 4, NM is equal to 4 by 3. 3 minus, yes, minus 1 by 4 will come. Minus 1 by 4 into. So if we see R1 is for this lens positive and R2 is negative, because so here object is, here we will take consider, because this side is silver now. Here we should not take object. So this side. So then R2 is positive and R1 is negative. So R1, this is R1 is positive, R2 is negative. Therefore here positive will come. That equal it is, if two are same radiuses, then 2 by R will come. Plus again 2 by R mirror. And positive only. It is a confirmation. 2 by R. So now here it is. The power of the lens in this case when water is filled, power of the total power of this combination of silvering lens is minus 1 by 2R plus 2 by R. So that equal to 2R is LCM. So now minus 1 plus 4. So that equal to plus 3 by 2R. See, answer plus came. So it behave like a power is positive for concave mirror, concave mirror. So now if R value is given, you can find out. Therefore, total focal length of this combination is, this combination we should not tell, because it is not combination, it is a silvering lens. That's no combination. In another class we'll discuss. So that equal focal length is equal to 1 by power, therefore 2 by 3. In calculation, in finding the VRU in mirror formula, you have to take this focal length as minus value. So minus 3 by 2 R you have to take. In calculating the U value or V value for given U value of object distance, or in the place of object distance, you will give size of the image, some other values you will give. But in calculation, you have to find substitute this focal length value. So see, conclusions I will tell. So in calculation of power formula, P total power is equal to 2PL plus PM. And the silvering lens behaves like a mirror that depends on the side which is your silvering, side of silvering. So now if you take examples or application of in this case, so you'll find out P. So P value positive means it is concave mirror. The P value, final P value is negative means convex mirror. So indirectly you can say by seeing these diagrams, here this mirror behaves like this lens, silvering lens behave like a concave mirror, because after silvering you will come to the mirror shape, concave mirror shape. So that is plane mirror means plane surface means plane mirror, like that. So now the next conclusion. So focal length. So while you are substituting the focal length, if it is a concave mirror, no negative you have to take in problem mirror formula. In mirror formula, you have to take focal length is positive means concave mirror means negative will take. Convex mirror means positive will take. This is concave mirror and it is convex mirror. Positive for convex mirror, negative for concave mirror. And U value and V value will substitute, will find out the remaining. And last case is in power of lens, calculation of power of lens. Everybody should remember that refractive index NL by NM. So in books they will write N simple. In the place of N, we have to take relative refractive index like this NL by N. So given value of NM and NL decides the power of the lens is positive or negative. So these are the conclusions related to silvering of lens and calculation of the power in case of silvering of the lens. Thank you guys. I hope you